Suppose we are given with a contingency table as this. From the table, we are supposed to accept or reject the hypothesis that smoking causes cancer. That is to check whether there exists any relationship or association between the two levels of smoking, namely yes and no, and the two levels of cancer, namely yes and no. Chi-square test for association is a type of statistical hypothesis test, which can be used in this case. The general layout of such types of problems is given in the table. We have two categories, Category 1 and Category 2. Category 1 has C levels and Category 2 has R levels. The frequencies corresponding to each possible combination of these levels is shown in the table as F's. The row totals are denoted as F1 dot, F2 dot, etc., whereas the column totals are represented as F.1, F.2, etc. The total frequency is denoted as F double dot. Our problem is to check whether the levels of one category influence the levels of the other. Now for doing the test, we must recall some basics in probability theory. We know that the classical definition of probability states that, under some conditions, probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes. Using this definition, we can see that the probability of an individual falling in the first row is F1 dot divided by F double dot. Similarly, the probability of an individual falling in the row I is Fi dot divided by F double dot. On the other hand, the probability of an individual falling in the first column is F.1 divided by F double dot. Similarly, the probability of an individual falling in the column J is F.J divided by F double dot. Now, if the null hypothesis is true, we expect certain values for the frequencies in each cell. In this case, since the levels of both categories are independent of each other, the probability of an individual falling in the row I and column J is Fi dot into F dot J divided by F double dot. We compute the expected frequencies by multiplying the above probabilities with the total frequency F double dot and tabulate these expected frequencies together with the given frequencies in a table. If our hypothesis was right, every expected frequency should match with the corresponding frequency given. Now, we are likely to see that in a given problem, in most of the cells the given frequencies and the computed frequencies are different. Then how can we conclude that our assumption is right or wrong? For this, all the difference in expected and actual frequencies should be taken into consideration. So we make a test statistic of the above form. By looking into the statistic formula, we can see that the statistic will take large values if the differences are large and it will be close to zero if the differences are negligible. So a large value of the statistic is an indication that our hypothesis is wrong.